This is a demonstration of using the LupinPet application to detect large transactions, and in this case I'm going to show an example of detecting a large web page. I'm going to use a test web page that's available up on the Lupincorp website, and also show you that using this application you can drill down and find what's the actual cause of, in this case, the large web page. So let's start off by starting up a new trace. I'm going to call the trace 15 large page. I'm going to put in the IP address of the Lupincorp website. I'm going to filter on port 80 traffic, so I'm only looking at the web traffic. I'm going to start up the trace. I'm going to go to the test page that I have with a large image on it. It's actually got a 1 meg image on there, and as you see on the page it says hit Control F5 will actually refresh the page, all the page content. So I stopped the trace. The trace is now in my list of trace files, and you see in the conversation detail it's showing me some summary information about the conversations that make up that trace. You see traffic was between my machine, which is the friendly name for my IP address, and Lupincorp. It was just over a meg of data was transferred, and it took 2.5 seconds. Now going into turn details will tell us more about the transaction. I see here there's actually 4 turns making up this transaction. We see there's one large long running turn here that's probably going to be the cause of any delay we saw. So let's have a look at each of these transactions. First one is the initial get on the page, and it comes back with the HTML of the page, and then it starts retrieving the resources that are used in this page. See here, this is retrieving the 1 meg image, so this tells us that really that 1 meg image is the cause of any delay for this transaction. Otherwise, if these images were a lot smaller, we'd kind of expect this page to finish more in this area here, probably in the 700 millisecond range. Also see other resources that were retrieved in this transaction. Looks like a style sheet here, cascading style sheet, and also an image that's used in the header. We can also look at this data in the time series graph, and let's just break it down by 100 milliseconds and look at the bits per second transfer rate. We see here the request is really not using much bandwidth. That's the red line here, but the response here, you see the transfer rate got up to 6 megabits per second. I'm just running across the internet to do this, so that's probably fairly typical of an internet transfer rate. Knowing this information, I'd know that I probably need to compress that image, break it up maybe so it can be retrieved in separate pieces, and also maybe look at the caching for that page to see whether the image needs to be reloaded every time. I can also do some tests with this, say using a network emulator, and I have one of the traces from earlier when I looked at the same page using network emulator, and this shows an example of going to the same page but across something like a connection between US and Australia, and you see now the transfer took 9 seconds for the same amount of data. You see here I actually had the emulator set up to transfer at 1.5 megabits per second, which is kind of typical for international connections, and again you see the time series graph is actually reflecting that. It's showing me that it was transferring pretty much around maxing out at 1.5 megabits per second. I'm also seeing some drops here in bandwidth, which may indicate some windowing problem. I could look at things like average window size, and you can see here some dropouts here, which may indicate that there's some throttling going on the client as well. If I look at the turn details, it's just reloading it at the moment. Okay, so it looks very similar to the previous trace that was taken more locally, but now you see that the time for the get of the image is closer to was it 8.5 seconds.